Hi everyone, and welcome to this tutorial session. Today we'll continue with our series of questions on inequalities. We're going to look at the following two questions. The first one, we'll find the solution set for the question x into x squared minus 6 greater than or equal to x squared. And then in the second question, the absolute of the rational function x squared minus 9 all over x plus 1 is equal to 9 minus x squared all over x plus 1. Okay, so please follow the solution from the beginning to the end because a lot of explanation will be given at each important step that we have to follow. Okay, let's start. The first question we have to solve for the set of values of x into x squared minus 6 greater than or equal to x squared. Okay, this is another tricky inequality here. We can see that there is x on the left hand side and there is x squared on the right hand side, and the temptation that some people may have is to go and divide both sides by x, because we can find x here. If you do this, this will be wrong, again, for the simple reason that we don't know the value of x. With inequalities, if you are dividing both sides or multiplying both sides by a negative quantity, then this inequality sign must reverse. It is a rule that must not be forgotten. If you do this division, we don't know the value of x. What if x is negative? Automatically it means I will have to reverse this inequality sign. So to avoid that situation, we don't know the value of x. To avoid that situation, what we need to do is to take this quantity, this x squared of the right hand side, to the left hand side. So we're going to get x into x squared minus 6. This is positive x squared. Bringing it this way, it becomes minus x squared. Now we have greater than or equal to 0. We have 0 on the right hand side. Here we can see that x is common. We'll factorize out the x. We'll factorize out the x. We'll factorize out the x. This is the x here. When we remove it from here, we have this lot, x squared minus 6. And this is negative x squared. When we remove x from there, we have negative x greater than or equal to 0. Okay, so at this point we have inside the parentheses here we have a quadratic expression. So let's arrange it very well. Let's arrange it. We have x into x squared. We'll bring this one first, negative x, then negative 6. Now we see a quadratic clearly. In the parentheses we have a quadratic. So we're going to come up with two factors. We have to factorize this quadratic expression. Using the factorization method, we look for two factors of negative 6 whose sum is negative 1. Okay. Remember, if you have to collect your information here, the coefficient of x squared is 1, coefficient of x is negative 1, and the constant term is negative 6. So we look for two factors of negative 6 whose sum is negative 1. Those two factors are negative 3 and 2. Okay, if we multiply negative 3 to 2, we have negative 6. If we take their sum, negative 3 plus 2, we're going to get negative 1. So we're going to replace this negative 1 here, this coefficient negative 1, with the sum of negative 3 and 2. Okay, so we have x into x squared. Now, instead of negative x, we're going to have negative 2 plus 3. There's the plus here, x, then minus 6. Okay, greater than or equal to 0. Okay, so this gives us x into, we open this parenthesis with respect to this x, into x squared, negative 2 multiplied to x, negative 2x, positive 3 multiplied to x, positive 3x, minus 6, greater than or equal to 0. Now, if we take the first two, we factorize, and we take the second two, we factorize. X into, when we take the first two, we see we have x is common. So we're going to have x outside. When we factorize out x, we're going to have x minus 2. Then we'll take the second two terms, we see that 3 is common. So we'll say plus 3 into x minus 2 greater than or equal to 0. Okay, our factorization process does not stop here. We still have x minus 2 here and x minus 2 there. So we get x into x minus 2, which is common. When we remove it from here, we'll have x. When we remove the x minus 2 from here, we'll have positive 3. Okay, so we have factorized the quadratic expression that was in the parentheses. So we have found the two factors. Here are the two factors. So this is what we have. We have the product of 1, 2, 3 terms greater than or equal to 0. So the next thing from here is to get our critical points. What are our critical points? Critical points are those values of x that will render this expression 0, this expression 0, this expression 0. So the only value of x that will render x0 is 0. So the first critical point is x equals 0. The second critical point, we set this equal to 0 and solve. So if we set that to 0, it means x equals 2. That's our second critical point. We also set this one to 0 and solve. If we do that, it means our next critical point is -3. So we have 1, 2, 3 critical points. We'll now go on our number line. We indicate those points in the right two positions on the number line. -3 is the smallest, followed by 0, and then followed by 2. So we have 1, 2, 3, 4 zones to analyze. We're going to analyze using this expression. Okay, so let's do our analysis this way. Let's do our analysis this way. Our analysis will be on this expression. So let's write it again. X into x minus 2, x plus 3. Okay, so now let's take a value from this zone. -4 is a good value. It's found in this zone. We'll put it there. We'll have -4 into -4 minus 2 is -6. -4 plus 3 is -1. So we're interested only in the sign. So negative multiplied to negative, positive multiplied to negative, negative. So here we'll have negative. Let's take a value in this zone. A good value in this zone could be -2. -2 is found between -3 and 0. All right. So we'll carry out the same analysis. So in the place of x, we'll put -2. So we're going to have -2 into -2 minus 2 is -4. -2 plus 3 is +1. We're interested only in the signs. Negative multiplied to negative, positive multiplied to positive, positive. We take a value between 0 and 2. 1. +1 is found in this zone. We'll carry out the same analysis. +1, 1 minus 2, -1, 1 plus 3, +4. We are interested only in the sign. Positive multiplied to negative, negative, negative multiplied to positive, negative. We take a value in this zone, +3 or +4, +5. Any number greater than 2 will go. All right, we'll carry out the same analysis. If we take +3, we'll have 3 here. 3 minus 2 is +1. 3 plus 3 is +6. Everything is positive. So the sign there is positive. Okay. Our analysis complete. Now, which of the zones 1, 2, 3, 4 is going to constitute our solution set? Again, we look at our final expression, the expression from where we got our critical points. The symbol there, or the sign, the inequality sign there is greater than or equal to 0. That means positive. greater than or equal to 0 is positive. We should always remember that. So where do we have positive? We have positive here and we have positive here. So those are the two zones that will constitute our solution set. So for this first inequality, we'll say our solution set will be all real values such that we take this. How do we represent this interval? -3 less than or equal to, because it is greater than or equal to. So -3 less than or equal to x less than or equal to 0. -3 less than or equal to x less than or equal to 0. Or elements in this zone, all values of x to the right of 2, including 2. So x greater than or equal to 2. X greater than or equal to 2. Okay, so this gives us our solution set for the first inequality. Okay, the second question, let's take the second question. Please don't hesitate to indicate your appreciation on the comments. We would love to read your comments about our work so as to improve. The second question says we should find the solution set of this absolute expression. This absolute rational expression, x squared minus 9 all over x plus 1 equal to 9 minus x squared all over x plus 1. Okay, we should find the solution set of this absolute value equation. Now, how do we proceed when we have this type of equations? We'll have to recall our definition. Recall the definition of the absolute sign, the absolute function. The absolute function of x, the absolute x, will be x if x is greater than or equal to 0, or negative x if x is less than or equal to 0. We should always remember that. All right, so if we look at this, what we have in here, we can consider all of this as x. Even though the small x there, we can have a picture of, well, if we want to use another letter, we want to call all of this x squared minus 9 all over x plus 1, we want to call it a. It will be the same definition. It will be positive a if a is greater than or equal to 0, or negative a if a is less than or equal to 0. So if we don't want to use x, we can use another letter. So if we call all of this rational expression, x squared minus 9 all over x plus 1 as a. Now, what situation do we have on the right hand side? Remember, this is equal sign. This is equal sign. So what do we see on the right hand side? Is it the positive entity that we have inside the absolute sign value, or the negative of the entity that we have inside the absolute sign value? Okay, so let's look at it. If we look at it, we have here 9 minus x squared. All right, the denominator is the same, x plus 1, but look at the numerator. This is 9 minus x squared, but up here is x squared minus 9. So if we look at it carefully, x squared, what we have here, 9 minus x squared, is the same as negative into x squared minus 9. Okay, so we can see that actually what we have here is the negative of what we have inside the absolute sign value. From our definition, the negative. So what is the condition we must respect? The condition we must respect is that what we have inside the absolute sign, this is positive a, what we have inside must be expressed as less than or equal to 0, since we have the negative. This one here is the negative of this. So following our definition, that will only be true if and only if what we have inside here is less than or equal to 0. All right, so we now conclude by saying, if this is equal to this, then this condition must be fulfilled. What we have inside here must be less than or equal to 0. So this is the inequality that we have to solve here. Since we are given this inequality must be fulfilled from this our definition. So this is the inequality that we have to solve. Okay, so when we look at it, the right hand side is already 0, so all we have to do is to get our critical points. Okay, get the critical point of the numerator, critical point of the denominator. The numerator is actually a difference of 2 squares, because it can be written as x squared minus 3 squared. And applying the difference of squares identities, we have x minus 3 into x plus 3, all of that, all over x plus 1 less than or equal to 0. Okay, so which are those values that will render the numerator 0 and the denominator 0? So those are our critical points. Our critical points are gotten. We set each of them equal to 0. If we set this to 0, it means our first critical point will be 3. If we also set this one to 0, it means our second critical point is negative 3. And then if we also set this one x plus 1 to 0, it means our last critical point will be x equals negative 1. So our critical points are x equals 3, x equals negative 3, and x equals negative 1. Now let's put them on a number line and carry out our analysis. So let's write the critical points again. Critical points. We have negative 3, negative 1, and we have negative 3, negative 1, and 3. We have 3 critical points. Now let's place them on a number line and see which of the zones give us our solution set. Negative 3, negative 1, positive 3. We have 1, 2, 3, 4 zones to analyze. Okay, now we're going to analyze using our expression that gave us critical points. We use this expression. So let's write it again here. We have x minus 3 into x plus 3 all over x plus 1 less than or equal to 0. Now let's take a value from this zone, for example, negative 4. We're interested in the signs. A value in this zone, for example, negative 4, and put there negative 4 minus 3 is negative 7 into negative 4 plus 3 is negative 1. Negative 4 plus 1 is negative 3. All right. Negative multiplied to negative, positive, positive divided by negative, negative. So here we have negative. Let's take a value in this zone. In between negative 3 and negative 1, there is negative 2. So a good value there is negative 2. And we'll put here negative 2 minus 3 is negative 5. Negative 2 plus 3 is positive 1. Negative 2 plus 1 is negative 1. We're interested in the sign. Negative multiplied to positive, negative divided by negative, positive. Let's take a value here between negative 1 and 3. 0 is a good example. 0 is found in this zone. So if we put 0 here, we'll get negative 3. We put 0 here, we'll have positive 3. We put 0 here, we'll have positive 1. All right. So we'll have negative divided by positive, negative. We take a value here, for example, 5. Okay. 5 minus 3, positive 2. 5 plus 3, 8. 5 plus 1, positive 6. Everything is positive, so here is positive. So which of those zones constitute our solution set? We look at the sign, the inequality sign in our final expression. The inequality sign says less than 0. Less than 0 means to the left of 0, and all values to the left of 0 are negative. So where we have negative will give us our solution set. We got negative here, we got negative here. So our solution set will be in this zone or this zone. Okay, so from here we now conclude what is our solution set. Our solution set will be all real values of R such that x, all real values x, such that x is less than or equal to negative 3. X is less than or equal to negative 3. Or here we have what? X should be between negative 1 and positive 3. Why have we used less than or equal to? Because our original expression talks of less than or equal to. There's the less than or equal to, so we have to use less than or equal to. But there is a situation here now in this solution. Pay attention. We will not come here and say negative 1 less than or equal to x less than or equal to 3 for this zone. We will not do that. The reason is simple. If we say negative 1 less than or equal to x, then we are saying there's the possibility that x can get the value negative 1. But when we look at the denominator here, we have x plus 1. If x takes the value negative 1, this expression will become undefined. The denominator will become 0, and dividing by 0 is impossible. And so the whole expression will become undefined. So to avoid that situation, we take away the equal to from the inequality sign. And so we have negative 1 less than x less than or equal to 3. That gives us our solution set for the second inequality.